Hello everyone, this is State 12. I'm doing array problems in medium section. We'll continue with the next question. Next permutation. Sorry for disturbance. Next permutation. A permutation of an array of integers is an arrangement of its members into a sequence or a linear order. For example, for array this, the following are all the permutations. Okay, so basically if this is the array, next permutation will be the next alphabetical array or ordered greater, which is greater than this. So 1 3 2, basically that will be the next permutation. I think the next permutation of an array of integers is the next lexicographically greater permutation of its integer. For more formally, if all the permutation of an array are sorted in a container according to their lexicographical order, then the next permutation of that array is the permutation that follows it in the sorted container. If such arrangements are not possible, the array must be arranged in the lowest possible order, that is sorted in ascending order. Okay. For example, the next permutation of this would be 1 3 2. Next permutation of this would be 2 1 3 is smaller than this, so 3 1 2, and for this it is not possible, so we will just reverse the numbers. Okay. Given an array of integer, find the next permutation of nums. The replacement must be in place and use only constant extra memory. Okay. So the brute force approach for this would be that we find all the permutations of this number, right? We find all the permutation and store it in a list of arrays, and then we'll find in the list the next number to this. We'll keep it sorted, and then we'll find the next whichever will be the next array in this after this. So basically what I mean is, first of all we'll sort this array. So when we have got nums, let's say I will change it, so it is 2 3 1, right? So initially we will sort the array, it will become 1 2 3. Then we'll take a list of arrays, and in this we will store all the possible permutation in lexicographical order. So array will contain 1 2 3, same this thing, array will contain same this thing. Then we will this list will contain these arrays, and then we will iterate over this list and find the original array. So original array is present here, and then we will check the next one is this, so this is the answer. And if it is present at the end, that means it is the smallest, so we cannot find or it is the greatest possible, so we cannot find a greater permutation, so we will just return the first one, which is the smallest or in ascending order. And in order to do so, how we can write the code is, first of all we will sort the array. I'll change it to Java. We can use the inbuilt sort method, arrays.sort nums, and this is how we do it. Java sort inbuilt array sort inbuilt method. How do we write it? Arrays.sort, right? That should be fine. Basic is arrays.sort. Okay. And then Once it is sorted, then we will now we need to find all possible permutations. So this is the sorted array. The next permutation will be swapping the last two digits, and for the next permutation will be starting with 2. Okay, so basically we'll keep the first one. Let me try with the 4-digit number to see how we can do it. So if this is the initial array, sorted array, then first will be this, second will be 4 3, third will be 1 3 2 4, then 1 3 4 2, then 2 1 3 4, and so on, right? So in first one we need to swap last two digits. Then once that is done, in next one we need to put 3 here and swap 2 and 4. 2 and 4 will remain in same position. We'll keep 3 here, and then we'll apply the same thing on the remaining part, and so on. So we can do it in using a recursive method. We'll first apply the same next permutation on the whole block, then we should apply the permutation on first, which will internally apply permutation on this, which will internally apply permutation on this, and so on till we have 1 digit, and then it will try to find the greater number out of these two, and so on. I think this is doable, but what they are saying is we want to do it in place without using extra space, and also the time complexity of this would be huge. So the time complexity will be around n cross n, right? The other good approach of this to do this would be, while doing this I came up with an idea that if this is the number, then no, not this. If this is the number, then result is basically 1 2 3 and 5 4, right? We are just swapping the last two digits, and because to find the next greater permutation, we just need to make changes to at the right of this array and as less as possible. So if it is possible to find the next permutation by making swapping these two numbers, then we will do that. We will not touch 3 because that will not give us a correct result. So if it is possible to do it with these two, we will swap these two, and that is correct. Now if the question is 1 2 3 7 and 4, now in this case it is not possible because when we'll swap 4 and 7, it will become 47, which is smaller than this. So we have to use 3 as well. So in this case, the iteration will be 1 2 3, 1 2 4, and then 3 7, and then 3 and 7. Similarly, if we are at 1 2 and let's say 7 8 9, and let's say let's take a smaller number, so let's say 5 6 7 and 1. Okay, so in this case what will happen, we cannot swap 71, it will become 17, which is lesser number. So what if we swap 6, so it will become 167, which is correct. Let me take some other example. So what if it's 765, Hana? Now in this case we cannot swap this. What if I update this as well? Is it possible to make a greater number with these three? It is already the greatest possible. 651 is the greatest. We cannot make a greater number using these 3 digits. Similarly, 7651 is the greatest. We cannot make a greater number using these. So we will have to update 2. And also it makes sense, because what if the number is 7654321? In this case, it is already the greatest. We cannot make a greater number by updating 7 here, because there is no greater number than 7 in this. So the result, we don't have a result in this, and we'll have to just reverse this and give the result. But in this case we can update 2, and we will update 2 with the next higher number. Which is the next higher number? Next higher number than 2 is 5. Right, we cannot update it with 1 because it will become smaller. So what we'll do, we'll update it with 5, and then whatever is remaining, what is remaining? Remaining is 2 7 6 and 1. 2 7 6 and 1, right? 2 7 6 and 1. So what will happen, we will just keep it 1 2 6 and 7. So this will be the next number after this. So what we are doing here is, first of all, 2 and 5, we are swapping 2 and 5. In this case what we are doing, we are swapping 2 and 5, so it becomes 5 2 1, and then these numbers should be from least to greatest. So basically we can say that we are swapping these, or we can sort it in ascending order, but I think this will always be from bigger number to, it will always be sorted in descending order, because that is how we are finding the next number. So simply we can swap it, and then we can rearrange it from just reverse this part of the array. That will give us the result. So the intuition is that when we have 4 7, then we need to find this digit, the last digit which needs to be updated. In this case we don't have that. In this case it was 2. And why 2? Because we want to find so these are increasing, and then the first decreasing number we need to find. Even in this is the first decreasing number, so we are updating from here. In this is the first decreasing number, so we are updating from here. This makes sense. So once we have it, then we will swap it with the number just greater than it. So number just greater than 3 is 4, so we will swap it with 4, and 4 will come here, right? And then rest are present in increasing order. 8 2 कहाँ से आ गया? Rest are present in increasing order, right? Similarly इसमें next decrease ये वाला है, and then we will swap it with just greater, इससे कौन सा है? 5. So we'll swap it with 5, and rest are in decreasing order. I think I got it. So I'll write the code for it. What we will do is, first of all we need to find the this number which is the first decreasing number, first number which is less than the previous number. So for we will start iterating from the end and from this digit. So int I equals to n minus 1, where n is nums dot length, length. Okay, I is n minus 1, I is greater than equals to 0, I minus, and we will check if this number, if I we can do n minus 2 so that we can compare it with the next one. So if nums I, okay, nums I is this, we are at this, if nums I is less than, if nums I is less than nums I plus 1, right, then we can say that this I is the correct index. So let's take a index equals to 0, or not 0, let's take it a arbitrary value so that we can also figure out that if it is possible to find it or not. If this is the case, then index, we will never find index. So let's mark it -1, and now we will update index equals to I, and we don't need to go further, so we'll break. Now we will check if index is still -1, that means we haven't found that digit. So that means we just need to reverse this array and return. So I'll write a reverse thing here because we need to reverse later also. So I'll write a reverse currently and then we'll update it. And then next what we need to do, now we have found I, so we will start iterating from end, and when we will find the greatest number, a greater number than this, then we will swap it. So for int I equals to n minus 1, I is greater than equals to 0, I plus plus, and if nums I is what, nums I is greater than nums index, that means we have found the number, right. We will swap these two. So swap, I'll write the swap method as well. So swap nums I and index, okay, and we can break also from here. And then we need to reverse the elements from index plus 1, because index is now at correct position, index value is correct, the index plus 1 से लेके n minus 1 तक, and this needs to be reversed from 0 से n तक, n minus 1 तक. Also we need to write a method ये तो क्लास का ब्रैकेट कहाँ है फिर, shall I put it, and then we need one more, I'll remove this, and we need one more method, public void, method is swap will take int nums, int I, int j, int temp equals to nums I, nums I equals to nums j equals to temp. Swap is done, and then we need to write this method: public void reverse int nums and in I से into j तक we need to reverse the elements. Now to write the reverse method, what we can do is, एक तो we can either sort it in descending order, or what we can do to reverse is we can swap these numbers. It will reverse. Is it 4 5 6 7 8? if we swap the number, so 8 से 1 को swap करेंगे, 1 को swap करेंगे, then 7 से 4 को 2 को swap करेंगे. हाँ, so it will work ना. फर्स्ट डिजिट और लास्ट डिजिट को swap करना है ऐसे करके. and so we want the middle element तक ही swap करना है. while I equals to j or I is greater than equals to j, what we will do is, ऐसे कर लेते हैं. what we will do is we will swap nums I and j. nums I, तो swap वाला मेथड ही लिख देते हैं. swap nums I j को swap करेंगे, and then I plus plus and j minus minus. Will it work? It should. Let's see. swap तो हो गया. What happened? int silly mistakes. index 3 outer bound length. What happened? I equals to n minus 2. I is greater than equals to 0. I minus minus. यहाँ पे भी तो यही करेंगे. temp equals to nums I. swap कहाँ पे किया है? nums I what happened to nums I is where? कहाँ से फेल हो रहा है? यहाँ से कि ऊपर से? while I is less than होगा ना, it should be less than. if it's equal and greater तब थोड़ी चलाना. it is failing here. if index out of bound, index is -1, is it? -1 तो we have updated. and return. let's submit it. Great. Now in this the time complexity is order of n, because we are, let me see, So this is order of n, and reversing is also order of n, and this is also order of n. So time complexity is order of n and space is order of 1. This is done. Next is leaders in an array. There is no lead code option for this. Example leader. Where is the problem statement? There is no problem statement in the example. Directly example is there. Array है, ये output है 710. Explanation: the rightmost element 0 is always a leader. 7 and 1 are greater than elements to their right, makes them leaders as well. I didn't get it. इसका आंसर है 12, 22, 12 and 6. 6 is the leader because there are no elements after it. अच्छा, तो 0, whichever is the rightmost. Where is the problem statement? That we have to figure out. So the rightmost element is the leader, and 12 is the greater than all the elements to its right. Oh, okay. So we need to find all the elements जिनके राइट में उससे छोटे ही एलिमेंट्स हैं. So like 22, all the elements are smaller, then 12, all the elements are smaller, and 6, all the elements which are smaller, which are not there. I got it. Okay. This is also an interesting problem. Looks similar to the previous one. Let me open the lead code. I will just try to write it here. So this is the array. Six, or whichever number is at the end, is always in the answer, right? So 6 is always present. Now coming to 0, what we can do is we can keep track of greatest found so far. Greatest found so far. GF so far, girlfriend so far. So far, okay. Greatest found so far. Currently it is 6. Now we know that if we find any number smaller than 6, then that is not in the answer. So we start iterating from the end. We find 6. 6 is in the answer currently, and we can initially take greatest found so far as -1, right? We come at 6. We see that 6 is greater than this number, so 6 is in the answer. We move forward. We found 0, and we update greatest so far to 6. Now we found 0. 0 is not in the answer because it is not, we have a greater number. Then we have 3, again it is smaller than this. Then we have 12. 12 is greater than this. So what we will do is we will update greatest found so far to 12 and also add 12 to the list. Then next is 22. 22 is greater than this, so now this will become 22 and 22 will be added in the answer. Then we have 10. 10 is not greater than this, so 10 will be skipped. It's pretty straightforward. The time complexity will be order of n, and space will be order of n if we want to, because we cannot return these in the same array, so we'll have to create a new array just to return the answer. Just mark it as done. Let's move to next question. Is it a premium question? What happened? Longest editorial. Acha, link is not correct. Okay. Longest consecutive sequence. Given an unsorted array of integer nums, return the length of longest consecutive element sequence. You must write an algo that returns in order of n. Okay. So if this is the array, the longest consecutive sequence is 1 2 3 4. Got it. So इसमें 1 2 3 4 is the longest possible. And in this it will be 0 1 2 3 4 5 6 7 and 8. So 9 digits, all 9 are possible. So longest is 9. In this 0 1 2, so 3 is the answer. Okay, got it. So one way of doing this would be that I think the easiest way is if we sort this array 1 2 3 4 100 and 200, then we will take that max so far as 0, we'll start iterating from first element, and we will find how many consecutive we can create. So we will start iterating. This is in consecutive because this is greater than this. This is 1, I mean 2 is 1 plus 1, then 3 is 2 plus 1, then 4. Till 4 we have found. So we will keep updating max is 4. Now at this we know that this is not consecutive, so we will we'll keep track of a current also. Current will become 1 again. Now at this current is 2 and current is not greater than max, so we will not update it, and so on. So that's how we will find it. In this case we have to sort the array, so that will take order of n log n sorting, but they want it in order of n. But there is no limitation on space complexity, so what we can do is, other than this, we can take a hash map and we will take a hash map of size for all the elements. Like the size is, there can be negative elements as well, is it? So basically for each element we will store in the hash map if it is there or not, and then we'll start iterating the hash map and find the consecutive, how many consecutive elements are there. But instead of using hash map, what if we use a set? Because ordered set, the set is always in hash set is always in sorted order, so searching becomes easy. So what we can do is, first of all we store all the elements in the set, right? And then we will start iterating over this array, and we will find the element. We will, for each element we can check if so let's say it is 100, so we will check if 99 is there, and if it is there, then we will check if 98 is there, 97, till how many numbers it is possible to find in the set, and we will keep iterating the size, I mean counter. So what I mean is, let's say this is the array, so we will put everything in the set, and as I said, set mein to it will be in ascending order, it will be sorted. Now what, this is set, upar wala is array, this is set. Now what we will do is, now we will start iterating over this array. Okay, so first of all we find 100, and we will take a max so far, which will tell us the maximum, the result. Initially it is 0, and we'll take a current which will keep track of current size of consecutive elements. So current is also 0. Now we are at first element, we'll update current to 1, then we'll check in the set if 99 is there. If it is not there, we will just stop. Then we will check if 1 plus, I mean if all the numbers in positive side are there, how many numbers are there. So we'll check after 100 if 101 is there. It is not there, so we will stop. So current is 1 and max of r will also become 1. Now next is 4, right? So for 4, next number is 4. So for 4 we will check if 3 is there. It is there. So current first, initially current will be 0 after resetting, so current will become 1. Then 3 is there, current will become 2. 2 is there, current will become 3. 3 is 1 is there, current will become 4. But 0 is not there, so current will remain as 4. And then we will check the positive side. So 4 plus 1, 5. We'll check if 5 is there in the set. 5 is not there, that means current will remain 4 and max of r will become 4. Then similarly, next element is 200. Again we will not find any smaller or greater, we'll skip it. Then we have 1. So for 1 as well, we will check if 2 is there, then 3 is there, then 4 is there, and even smaller numbers and so on. So that is how we can find. I think this is a good approach, because searching in set takes lesser time. Let me try it out. So int n equals to nums dot length. Okay, and we'll take a set, hash set of integers, set equals to new hash set. And for int nums in nums, remind me later, bro. We will add the elements in set. So set dot, how do we add elements in set? Set dot put, is it java set add elements? set dot add है, ठीक है. एड ऑल भी एक ऑप्शन है क्या? सेट डॉट एड ऑल एक बार में ऐड करने के लिए. एड ऑल, और एड ऑल में S2, अच्छा दूसरा सेट ही ऐड कर सकते हैं. ओके ठीक है. सो आई विल डू इट लाइक दिस, सेट डॉट ऐड and we'll add num to it. Then then what we can do is then we'll start iterating over this array int num in nums, and we need to check if all these smaller numbers first. So we'll take two variables, int max of r, as I said, max of r 0, int current 0. initially current को हम 1 कर सकते हैं because we have found this element is also one element, and then we will check while set contains nums num minus minus. Let's take one more variable, int temp. And temp equals to num contain temp minus minus. Wait, but if we do this temp minus minus, till how many digits we will do this? Because minus में तो फिर ये minus infinity चला जाएगा. We'll keep checking it. That is not the right answer, no. We'll need a lower bound for this, and it can be negative, so we cannot put 0. It can be negative also. So how can we do this? Maybe we can find the smallest number and largest number in this array, and then we can compare it with that. Like for example, here we can check if it is greater than the if it should be greater than or equal to the smallest digit possible in this array, something like that. One more thing, if we have found the element, can we remove it from the set? Like for example, one more thing is there, that we if let's say if we know that one there is no smaller element than one, so in order to find the longest consecutive elements, we need to find the smallest number in this and the largest number in this. If we have the smallest number in this, then let's say we found 2. Okay, so we know that 2 3 4 is there in the set, but it is not the answer because 1 is also there somewhere. So we need to somehow find 1 initially. So what we can do is, we find for the answer there will definitely be one element which is the smallest, and then we have to find all the numbers greater than it in consecutive order. And once we have found out, let's say if 3 is in the answer, so it cannot be in any other consecutive number which is greater, right? If it is consecutive, if it is in this string, in consecutive element string, it cannot be in any other consecutive element string, so we can remove 3 from the set if we have found it. What I mean is, we need to find 1 first of all. So for that we can check that if in this array, if there is no element which is smaller than this in the set, if set does not contain, if set does not contains contains temp minus 1, that means this is the smallest one. Now this is the potential candidate to start the longest possible. So now we will find all the elements which are greater than this and remove them from the set. And now what we will do is, while while set dot contains temp plus 1, right? Set dot contains temp, we can remove 1 also, no? So set dot contains temp. If temp is there in the set, we will do current plus plus, and also we will do and also we will remove the element. So set dot remove this element. And we also will do temp plus plus, but again there is no upper bound in this. We have to somehow add the upper bound also, right? And we need to update this here. We can put it as 0. We can update it directly here because we are counting the current element as well. Okay, so we don't need to add, because once it stop containing, it will automatically loop out of this. I think this should be fine. And here we will check if max so far is less than current, then max so far equals to current, and then we'll return max so far. This should be fine. Let's see. Good. We'll check a few solutions. Let's see this one. There are what is this? First term we put into a set, turn input into a set that takes order of n, and then we ask a order of n whether we have certain numbers, then go through the numbers. If the number x is start with the streak, x minus 1 is not in the set, then test y and stop at the first number y not in the set. The length of the streak is then simply y minus x, and we got it. It is the same thing. Fine. I'm done for today. We'll close this.